In this video, we'll set up a Java 21 Spring Boot project and create an API which connects to MySQL to perform the standard CRUD operations. We'll use Docker to create the Spring Boot server and MySQL database. Let's start by initializing the project. So go to start.spring.io, which is an online tool that helps us generate our Spring Boot project. We want to create a Java project, so we select Java as the language. Under project, we have the choice between selecting Gradle or Maven for our build tool. And a build tool allows us to compile our code, manage our dependencies, run tests, and package our application into either a jar or a WAR file. Here we're going to go with Maven because of its stability, maturity, extensive plugin ecosystem, and it's a standard project structure and build lifecycle. It should be noted that Gradle may be a better choice if you have advanced dependency conflict resolution needs. Gradle also tends to have faster builds, however, it has a steeper learning curve, lack of standardization, and fewer plugins. We'll be creating a blog web application, so we'll adjust the name and the description to reflect that. So here we'll just put blog, and we'll just say blog project here for Spring Boot. We have the choice between packaging our application into either jar or WAR files. A jar file is a Java archive file used to package Java applications that can be executed directly by the JVM. A WAR file is a web application archive file used to package web applications. It is deployed on a web server like Tomcat. We'll go with a jar file, however, because Spring Boot includes an embedded web server, making deployment easier and more flexible, particularly for development purposes. And we'll choose Java 21. Our project will rely on some dependencies. To be able to create our web application, we'll need to add Spring Boot. Spring Web. We'll also want to enhance the developer experience, so we can use Spring Boot Dev Tools. We also want to connect to MySQL, so we'll need the MySQL driver. And also the Spring Data JPA. To get the Hibernate ORM to avoid writing SQL queries from scratch each time. So go ahead and generate the project. And if you ever need any future dependencies, you can go ahead and click Explore, and you can see the POM XML file. And this will be the code that it generates for us. So let's open that up in our project here. And here we can see that we've got the same files and folders. However, there's just this extra Dockerfile and Docker Compose YAML file here, as we'll be using those to set up the server and SQL database. So, as we mentioned before, in the POM XML file, this is where all of our metadata about the project and all of our dependencies will be. And if we need to add another dependency, we can just copy and paste the dependency in from the location that it will be looking at and bring that into our project, and we'll see that in the future. So one thing to note about the Spring Boot Maven folder structure here is most of the code is in source here. Now in my source here, I've got a main folder, and in yours, there's probably, for the time being, a test folder. So I'm not going to deal with testing in this video. So I've just gone and deleted that folder there. Also, this target file folder, this is where, when we compile our code, it generates all the classes for us. So basically, in the Java folder, that's where all of our code will be. Now, your probably doesn't have these 4 folders here, but you will have this blog application file. And this is just the Spring application where it gets bootstrapped to actually run the server. It doesn't actually do anything, but it just runs the server. So we'll go into these folders here in just a sec. But just to mention, we have this resources folder. And the resources folder, this is where we have all of our static resources. So that's things like files, images, videos, whatever things we want to serve. We could also have another database folder here where we could have our MySQL migrations, for example. However, we're going to do that automatically for development purposes. We can see also we got this templates folder. So this is where the templates files will be that generate dynamic content via template engine. So a common one of these is Timely, for example. However, it should be noted that JSP pages in particular are typically served elsewhere, which we'll look into in a later video. Most importantly for us is we have this application properties file, and this is where we're going to make our connection to the database with our connection details. So let's start by creating a Docker file. So in the root of the folder structure, we'll create a Docker file. And we want to use Maven to build the application. So we're going to need to break this into 2 steps. So we're going to need to build the code, and then we're going to need to serve the code. And we've chosen Maven to do that for us. So I've just chosen this package here. So from Maven 3.9.8, Eclipse Temurin 21, that was just one I found on the Docker Hub. You could use any of the Maven packages as you wish. And notice that I am having this as build because we're considering the build step to start off with before we can run the code. And so we have all our code in here. When we make changes, we want to rebuild that, recompile it, and then serve that. So what we want to do is we want to set the working directory for the build. So this is on the Docker VM, or I think of it like a virtual machine, similar to how we have Linux machines. So on that, not operating system, but on that Docker container, which will have all our software that will allow us to compile and run things, we'll create an app directory. And then we can copy the Maven project files. So basically we need to copy the pom.xml so it will know how to get all the dependencies that we need for our project. And then we copy all of the code from our source folder into the source folder in the container. And then we want to build the application. So we can just run an MVM clean package to do that. And then what we want to do is, now that we've got the generated jar file, we want to use a minimal Java runtime for the final image. So we're going to use OpenJDK 21 Slim. And the reason for that is using a minimal version is this is just for development purposes. We didn't need the whole lot, and it makes the build times a little bit and deploy times a little bit faster. So we get that, and then we can add a volume because we're going to connect to MySQL. We're going to need a volume to connect to the to make the changes between our file system and what's on the Docker container. So we'll just have this folder here called temp. And then we'll get the applications jar file. So we know that we've run this MVM clean package. And if you ever run a Java project before using Maven, you know that it'll build a target folder along with the jar file. So we can take that jar file as an argument, and then we can copy the jar file from the build stage to the final image. So we copy from this whole build stage here where we got the target. So we have this -- from build, and then we have this variable jar file, which we've created based on where the output would be in the build step. And we know we're in the app working directory that we set here. So in the app working directory, we built the file, which creates the target folder, which creates the jar. And then we'll just rename that to something simpler. So app.jar. And then we can just go ahead and we can just run that. So the entry point command here. So we're just calling the java-jar command to run the jar file, which will be in app.jar. So that takes care of creating the actual building the Java server, the Spring server, and now, the Java project. We also want to use MySQL. So since we are going to be using 2 services, not just the one, we'll make use of the Dockerfile, but we'll also run a Docker Compose YAML file to set it all up. So we'll just specify a version here, 3.8, which is just the Docker Compose version. You can check on the website. And then we're going to create 2 services. So the first service will be MySQL. We create that first because the Java API Spring Boot project depends on that. So we have an image which comes from the Docker Hub. So we'll get MySQL version 8. And this whole Docker Compose file, we're just having configuration in which when we run, all of the software will be created for us in the Docker container. So we just call that container whatever we want. We'll just call it MySQL. And then we will give it the environment variables because we need to have some sort of database and connection to the database. So we'll just have a database called blog. We'll start off by making a little blog project. And the MySQL root password. So we'll just give that password. And that's all we need. It's because the root username will just be root. And then in the ports here, now I'm mapping 3316 to 3306. So what this means is the Docker MySQL, it runs on port 3306. However, on my machine, that's what it'll be on in the container. But from my host machine, I want it to run 3316. And I'm doing that just because I don't want any clashes with any of the other MySQL stuff that I run on my computer. But you could make this whatever you like. Then, okay, so basically we want to, in MySQL, when we start and stop the container, we want the data to persist, of course. So this is why we make a volume. So for MySQL, we'll have this MySQL data volume here. And then we can add the volumes to the MySQL service, which takes the specified volume here. So MySQL data. And then we can just put it somewhere. So we put it in the standard spot, which you can just copy this here, which is the var lib MySQL. And now we'll create our Docker service for the Java Spring project, and we'll call that app. So for the build here, build will just be in the current directory. The container name, we'll just call it Spring Boot. Now the ports will have, once again, I am using on 8080 already on my machine. So when I make an API request to localhost, I'm going to call it specifically to 8090. And then I'll be able to interface with the Spring Boot server through 8090 from my host computer. But under the hood in the Docker container, of course, it'll be on 8080, which is the standard HTTP server. So in the environment, we'll need to connect from the Java API to the MySQL database. So we need to have this Spring data source URL, and we got this JDBC, Java database connection, and we're specifically using MySQL for our relational database. And we can use, instead of localhost here, since we've called our container name MySQL, we can have MySQL here, and inside this container it's running on port 3306 here, as the default should be for MySQL. And then of course we just connect to this particular database. So we've got the blog database here. So we'll need the username, which I alluded to before. We're using the root, so we'll just have root here, and then we'll have the password here. And this project depends on MySQL, so when it's building the container, it will know to start MySQL first, that service comes first. Now, one last thing is we want to have these on the same network, the Java server and the MySQL, just because fetching from the same network will obviously reduce latency. You don't have to do this, but for development purposes, this is quicker, although it should be quick enough regardless. So we have these networks here, and I'm just going to call it Spring Boot MySQL, and it has a bridge driver, which just means these two networks can connect to one another, same network, so that we can specify the network explicitly in both the services here. So we've created our Dockerfile and our Docker Compose file. So what we want to do now is we want to, and I should mention that this build here, this dot here, it will know to look at the inside the root directory and look at the Docker file. So if you've called that something else for whatever reason, which you probably shouldn't, you'd have to specify that. So now we take a look at connecting. So we got a brand new project, and we got these application properties here. And since we've named our project blog, it will give us the name of blog here. So what we want to do is we want to connect to MySQL. So we got the MySQL driver and we got the JPA. So what we want to do is we want to use the Java database connection that we've already specified here. And we will use this in our application properties. And then we're going to have the username and the password. Now, this part is important. We got this Spring JPA Hibernate DDL auto, and I'm setting this to update. And this is a very important point to take away from this video, is that I'm using update because I'm just doing this for development purposes. But if you already have a MySQL database and you don't want any modifications to that, and you don't want to accidentally create things or delete things or anything like that, the recommended approach in production, and even sometimes not in production, would be to have this set to none. And it's recommended to do the migrations manually. You can use a tool to help with the migrations, but you don't want to be interfering with MySQL automatically. But however, I'll leave this as update because, you know, this is just a demo project, doesn't really matter. And then they'll save me the effort of creating the tables and all that sort of stuff. So I'm going to show SQL. So in the logs, you'll get, better logging messages of what's the actual SQL query is going to be. and that's something else. So that's what I was alluding to before. We don't need this in our project, but there is a Liquibase dependency that we could use, and that would help us with migrations. But of course, you'd need to, specify them out. And I just decided that it's going to be easier to just do this automatically. So now that we have our connection, that's all we need for our connection, because the Java Spring framework will take this information and use our dependencies and be able to make that connection for us. So what we need to do is we need to create an entity. So we've got this entity folder here. And just to explain this folder structure for anyone that hasn't done built APIs before, basically the entity is the Java code that represents what the table is going to be. So for a post, for example, our MySQL data table will have an ID or have a, some sort of text for what the post body is going to be about. Maybe a date of when it was created or modified, who the user was that created, all these sorts of things. So whatever you want the table to look like, that's where you can specify it. And of course, if you have a table that already exists already, you could, use copy the column names and all of that. So the entity matches the table in the Java code. The repository, this is like an abstraction layer, and this helps. So rather than writing the raw SQL out every time, you could imagine select star from table X, all these common queries. Rather than writing them over and over again, we have this repository, and that just is a layer of abstraction that gives us all these seemingly magic methods that simplifies that. So we'll see that in a moment. And then service is sometimes you want to use more than one. You might need to make more than one modification to the database, or you might need a more sophisticated way to get the data. And the service is like a layer where you can combine methods that the Hibernate ORM exposes, and you could add transactional tags to allow for rollbacks in the case of errors and stuff like this. And then, of course, the controller is just where we're sending the HTTP request to the URL, the API endpoint that handles it for us. So we send data to the controller via a URL or an API endpoint, and then we expect to get some data back, such that the data adheres to the contract. So starting off with the post, we can see that we've got this class post here in this entity folder. And of course, if you had a bigger project, you could have nested folders. So you could have, let's say you have a whole auth section and a whole, whatever other section, you could break that into subfolders. Or you could actually make it more modular. I think this approach makes more sense though in a Spring project. So yeah, so of course we got the package that we're in. So we're in com.example.blog. In the entity folder here, we've got a class called post. I'll just get these imports. They will auto import for you probably. We specify the class as an entity, and we do that with the annotation that Spring provides us, and that better maps the Java file to the actual entity. So the table that we want to create an object or a class for is going to be the post table. And once again, we don't need to create the table because we got this update thing. So what it's going to do is behind the scenes, it's going to look at all these entity classes, and then it's just going to go ahead and create the tables here for us. But if we didn't have that, created for us, we'll need all the properties and the table name to be as they are, otherwise we'll get an error. So I'm just going to create an ID. It's going to be a long rather than an integer. Just, you know, imagine you got a social media application that has billions of posts. Now it's harder to change the MySQL. Well, you can't really change the MySQL data type later on. So it's better just to do it like this, even though it takes double the bytes. That's sort of negligible for an application, for like a web application like this. So we can annotate these using the ID. The ID is always like a special annotation because that's the thing that we have the key on usually, or we can index on it if we like. And, you know, we want to have the generation type to be auto-generated for us. So the ID can be auto-generated for us. So that's sort of a standard sort of thing. Then we just want to have some text for our string, which is a string, and then a date added and a date modified. And then we can go ahead and we can just create all the setters and getters for that. And then we'll create the post repository. So again, I'll just get those imports, which should auto import for us. And all we got here is we annotate the class with this repository annotation. And we name the interface something repository. We don't have to, but it's recommended. So whatever, a good rule would be to whatever the name of this class is, followed by repository, because that class is the thing that we're going to be using. So this is all we have to do. And this extends the JPA repository. And if you'd actually look into the JPA repository, we'll have a whole bunch of methods like save and all that sort of stuff. And that is a layer of abstraction. So we can make all our SQL queries. So let's actually see that in action. So we've got this post service here. We'll get these imports in again, and we'll label this service. And this should be done whenever you're using the repository. So what we need to do is we actually need to inject the repository. So we can auto wire the post repository, and they'll allow us to use all of the methods on it. Now it looks like we haven't created any, but we've extended this class here, and that's going to have all of the standard CRUD operations and main API operations that we'll need to utilize to interact with the database. So what we do here first, let's just do a get. So if we want to get all the posts, for example, we just have this post repository, and then we have find all. Now find all, like after you do the first time using the repository, you'll know the names of all these methods. So the main ones, they're quite intuitive. So getting all, find all. And of course you can look at the documentation if you're looking for something in particular. You know, find by ID, you pass the ID in to get one specific post. Otherwise you get null. Oh, and one thing I should note is on the entities and throughout our code base, we've used the uppercase object rather than the primitive. And that's because we want all of these things to be nullable. So that should be quite straightforward and intuitive. But just to, in case you didn't realize why, I think if you're new to Java, you sort of think you got to use the primitive because you're saving data and stuff like that. But in the grand scheme of things, it doesn't really matter. And you want to have the flexibility to be able to nullify any of the fields or anything like that. So, you know, I mean, if you're doing like a local helper function or something like that, you know, it doesn't really matter if you use the primitive or not, because in cases you know where it is going to be, say, a Boolean true or false. But, you know, you might want to have a nullable field and you want to have that flexibility. So there's not much harm unless you have some mission critical code and you're trying to squeeze out every bit of optimization you can in using the object versions. So yeah, if you can't find it, you have this or else null that you can just chain on. So we have this create post here, similar sort of thing. You pass in the post object. Then what we do is we actually create the date. So if we're creating a post, obviously we're adding and modifying it at the same time. So we have this local date time now. Now local date time tends to be preferred over just date, mainly because date is on its way to being deprecated if it isn't already deprecated, just because local date time handles things a bit better. But of course you could just use the date if you have some legacy code or anything like that that you're trying to maintain and expand upon. Update post, same thing. We need to get the ID of the post we're updating. Then we pass in the update post here. Honestly, this could be a patch, but just keep it as a put. Well, actually, see that in the controller. But yeah, basically, we just get the existing post, and we saw how we could get a post by ID. And this is sort of why we have this service, see how we need to be doing things. So we're not just getting the post, but we're also making an API call. We're using that, and then we're setting and modifying the data. And you can imagine you can get more complicated things, particularly if you have more than one non-get request and you need to handle transactions. So if, say the first API call goes through and something errors in the second, you might want to be able to roll that back. You could just have a transaction tag up here, and it makes it much simpler if you have this separated in its own layer of abstraction. So we just go ahead and save that and return the object. If there is no existing post, we just return null and we'll handle errors later on. And then finally delete post, you get it by ID, and you can just delete it by ID. So yeah, the main methods to remember is find all, find by ID, save, and save works for both post and update, and then delete by ID. They're the main ones for 90% of your API calls you make. So post controller, finally we can use or put it all together, and we can just add this annotation REST controller, and our API calls will be going to say whatever we've called the project, so slash blog, I think, and then this will go slash blog slash posts. And of course you can add this on top of the actual method itself, not just at the beginning of the class if you want a specific name for a particular GET request. So what we can do is we can just auto wire the post service, so we can access all of those methods here, so we can interact with the database using the CRUD operations. We can have a GET mapping here. Oh, so the GET mapping, basically each of the types of requests, so GET, post, put, patch, delete, has its own annotation. And it doesn't really matter what you call this, although it's better if it's descriptive. So if we want to get all the posts, we can just simply return the post service, get all posts. And we can do a similar thing, get post by ID. Now this time we're going to go to slash post, and we can optionally add in slash ID here. Notice that this is a path variable, so we have an annotation here for the actual what's inside the curly braces. So we've called it ID, so this will be able to work that out for us. Now if you had, let's say you had post slash ID as an API endpoint, and also post slash ID for whatever reason, you could just have another API endpoint. This is usually just used to, as you do different API versionings or something, if you basically want to, let's say you start an API, you built your Java server, and 5 years in the future that there's a requirement for the API endpoints to be standardized, you can just simply do something like that. So yeah, we just post that. All very basic stuff. So let me get rid of that. Create a post. We just use the post service to create the post. This time in the request body, we have the post. And I'll probably go into validation and error handling in a later video. I want to go into authorization as well. That seems to be a bit more exciting, but we'll set all this sort of stuff up. All the standard stuff you would need. Again, this could be a patch, but we can update the posts based on the ID here. And then finally, we have the delete mapping. So on the ID, we can just use the post service to delete it. And we don't actually need to return anything. And if we have something like this, we'll get a no content back, and we'll see that in quite shortly. So what we can do now is we need to start Docker. So the important thing to do is, if you don't already, make sure you install Docker Desktop, and you need to have it open as well. So make sure you have Docker Desktop open on your computer. And now that we've created our Dockerfile and our Docker Compose file, what we can do is we can start Docker. So the way we can start Docker is we can simply have something like this, Docker Compose up. Now, the first time you want to do this, you probably want to build the project. So you'd have a -- build. And if you make any changes, or particularly to any configuration or source code, you might want to rebuild this. Docker is smart, and it does cache things and makes it quicker on the next build. So the first time it might take 20 seconds or so. However, on future builds, it'll be like less than 5 probably, or less than 10 or something like that, depending on your machine. But if you ever get into a situation where you think the code isn't refreshing properly, and Docker's sort of cached something and it's not upgrading, and you've made a change, you can just do this -- build. Now, I've already done that. So I'm just going to run Docker Compose up, and you can see it running, and it basically takes all of the images, so MySQL and Spring Boot, it downloads it into basically like a virtual machine, downloads the software you need, and then it starts the project for you. So firstly, I can go into Docker here if I want. And if you ever need to look at the Tomcat logs or the Spring Boot logs, say you're logging stuff out, you can look at it here. And also you could look into MySQL to make sure that things are connected properly. If you get any issues making your requests. So let me just go ahead and open Postman here. We see we're on localhost 8090 /post here. Oh, so previously I mentioned that we'll be on /blog. You can I think it's different if you'd use a WAR or a jar file by default, and of course you can just specify that in the main file in the I believe it's not the POM, I think it's this file. There's some annotation you can use, or it might be here, to have a stub. So you could have /API, for example. However, let me make this GET request. So notice that it actually got something, right? So I just used Docker Compose up. I did an example post before I did this video, and it did it with this first post or whatever. And actually I did it a few days ago. You can see here on the 14th of the 8th. Today's the 17th of the 8th. Basically, this just proves that upon the Docker container being shut down and reopened, that the volume did work. So your MySQL data is saved. Now in production, you'd probably, again, I alluded to before, you probably wouldn't even put in a Docker container, not your database. And you probably want to do migrations manually. You could if you wanted to, but you know, you do what you need to do. So let's say we want to post something. For whatever reason, this is called edit a post. This should just be called post a post. And this is the first post. Let's say this is the second post. And we'll send that. And let's this should be get all posts. So let's run this. And we can see that we got the second post. And that has the different date here. So we can go ahead and we can get a specific post. So we can get post 1 or we can get post 2 if we wanted. Now let's go ahead and edit a post. So let's change the text on post 1. So we can see right now it looks like this. Let's just add edited to it at the end there. And then when we get our post, we'll have this edited here. And then finally we'll do the delete. So we take the post 2, we delete that. Here we can see we get the no content back. Oh, we actually get a 200 back, but probably should get a 204 on that one. The post should be a 201, but 200 is all right for now. And then if we go ahead and we get our post, we see that we get our singular post back. So that's the CRUD operations and the Docker setup for a basic development server. In the next video, we'll probably look into role-based authentication. Subscribe to my YouTube channel. I'll see you in the next video.